People need energy. Today, 80% of the world's energy comes from burning fossil fuels, primarily oil and natural gas. But the world's known reserves of these two fossil fuels will last only 10 to 20 years at current consumption rates. And burning these carbon-based fuels is dramatically increasing the amount of carbon dioxide, a greenhouse gas, in the atmosphere, leading to global warming. Fusion, the energy source that powers the stars, may be the answer to mankind's future energy needs. Fusion is a nuclear process in which a deuterium nucleus and a tritium nucleus, two forms or isotopes of hydrogen, are joined, or fused, to form a helium nucleus and a neutron. In this process, a tiny amount, just 38 parts in 10,000 of the mass of the hydrogen nuclei, is converted into energy according to Einstein's famous equation, E equals mc squared. But the amount of energy released is enormous. Fusing just 1 gram of deuterium and tritium releases as much energy as burning 740 million grams of oil. Today, over 200 scientists from around the world are working right here in San Diego to make fusion energy a reality at the largest operating fusion reactor in the United States, the D3D National Fusion Facility, located at General Atomics in Sorrento Valley. Harnessing the energy source of the stars, however, is difficult because the hydrogen nuclei must touch to fuse, but their positive electric charges repel each other. In order to overcome this Coulomb force of repulsion, we must shoot the hydrogen nuclei at each other at very high speeds so that they touch and fuse before the repulsive force pushes them apart again. Such very high speeds are obtained by heating the deuterium and tritium to very high temperatures. Because we are making a star on Earth so much smaller than the Sun, we need to heat the hydrogen to 10 times the temperature at the core of the Sun, over 100 million degrees. At such very high temperatures, the deuterium and tritium can't touch the walls of the container holding them. We use the Lorentz force of a magnetic field on moving charged particles to confine the hydrogen isotopes in a magnetic bottle, shaped like a torus or a donut. Inside the magnetic bottle, the deuterium and tritium fuse, converting mass into energy, which we use to heat water into steam to drive turbines that run generators to produce electricity. The only difference in how the electricity is produced is in the source of heat to make the steam. But fusion energy has several very important advantages. The fuel is inexhaustible. Ordinary seawater for deuterium or lithium to make tritium. The waste or ash is harmless helium gas. There are no greenhouse gases produced, and there are no high-level radioactive fission fragments and no risk of an uncontrolled meltdown. For these reasons, fusion energy, once achieved, can provide a safe, clean, environmentally sustainable source of virtually unlimited energy for thousands of years.